In the last video, we talked about the models for division. We talked about there's the repeated subtraction model or the partitioning model. So two different ways you think about how to divide something, or like the model for division. Models answer the question of why. Okay. Today we're going to talk, or in this video, we're going to talk about strategies for division, and there are 4 different strategies for division. Strategies answer the question of how do I do it? Okay, so if a student's asking something like, why is 0 divided by 3 equal to 0? Like, that doesn't make sense. Why is it like that? You would use a model to answer that question. If a student was asking, how do I do the actual process of it? How do I divide 27 by 3, that's when you would do a strategy for it. So I hope that helps you see the difference between a model and a strategy and when you need to use those two things. So when you're introducing division, you would start off with the models to get them to understand what division is, and then once they completely understand division, then you move on to the strategies for fluency and efficiency. So the first one we're going to go over is the standard method or standard algorithm. So this is what you more than likely learned in school. So let's divide 343 divided by 7 using the standard algorithm. And if you remember, this is where you're at the 7 on the outside. You put your division sign and put 343 on the inside. And then you go piece by piece. So 7 goes into 3 0 times. It can't go into 3. So then you think 7 goes into 34. Well, 7 times 4 is 28. So I do 4 times 7 is 28. Write it underneath and subtract them. 34 minus 28 is 6. And then I bring down my 3. 7 goes into 63 9 times. And 49 times 7 is 63. Subtract. I don't have a remainder here. So 343 divided by 7 equals 49. Okay, so that's just the standard algorithm. So now let's move on to the scaffolding, the new stuff. So the scaffolding strategy for this, so this is scaffolding. I still write the problem the same way, so let's do the same problem. 343 divided by 7. I still write 7 into 343, but this time instead of thinking of how many times does 7 go into 3 or 34 or so on and so forth, you think of it in pieces. So I can think, well, I know 7 at least goes in there 10 times, just because that's an easy number to do in my head. You could do whatever number you want to. You just kind of want to do some easy numbers. So I know it at least goes in there 10 times. So if I divide 7 in there 10 times, 7 times 10 is 70. I need to take away 70 from that. And that leaves me with 273. So I still have 273 left. Well, 7 will go into 273 10 more times after that, right? So 7 times 10 is 70. When I subtract that off, I'm left with 203. Well, I know 7 goes into 203 10 more times. So 7 times 10 is 70. When I subtract that off, I get 133. Well, 7 goes into 133 10 more times, right? 7 times 10 is 70. 133 minus 70 is 63. Well, now I know 7 goes into 63 9 times. And 7 times 9 is 63. And there's nothing left over. So my answer here is all this added up, the sum. So your answer is the sum. And in this case, my answer is 10 plus 10 plus 10 plus 10 plus 9, which is 49. Okay, so this is similar to the standard algorithm. The big difference is I don't have to do it exact. I can kind of like work it out in my head a little bit. I know it goes in 10 times or 20 times or 100 times or whatever number seems obvious at the moment, and then work through that. Okay, so we can do another one. just like that. Let's do the problem. Let's do 96 divided by 8. So here's just an extra example to practice that. If I wanted to do 96 divided by 8. So 8 goes into 96. So again, I know 8 goes into 96 at least 10 times. Like that's an easy number to do in my head. And 8 times 10 is 80. So when I subtract that off, there's 16 left over. Well, 8 goes into 16 2 times. 8 times 2 is 16. When I subtract that off, there's nothing left over. So my answer is the sum of this. So 10 plus 2 equals 12. So that tells me that 96 divided by 8 equals 12. Okay, so that is scaffolding. The next one we're going to do is, and real quick, there's not necessarily a wrong answer or a wrong, okay, so like as long as you get the right answer, there's not a wrong way to do it. Like you might have said, well, I can see right off the bat, I know that 7 times 40 is 280, so I could do 40 first and then do 9 last. It doesn't matter what these numbers are as long as you're not doing the standard algorithm, as long as you're splitting it up into pieces. Okay, so the next thing we're going to do is the missing factor method. So the missing factor method is similar to the missing add-in method that we did with subtraction. So instead of, we're going to do the same problem, 343 divided by 7 equals, I don't know what it is. Instead of thinking of it like that, let's think 7 times what equals 343. Well, so let me break it apart into pieces. I know 7 times 10 is 70, right? 70 isn't quite there to 343 yet, so let's do some more. I know that 70 times, let's say 30, is 210. These two add up to be 210 plus 270 is 280. I'm trying to get to 343. How much am I short? I'm short 63 now. So now let's do 7 times 9 is 63. Do these add up to be 343? 70 plus 210 plus 63 is 343. So now my answer is the sum of the boxes. Okay, so my answer is 10 plus 30 plus 9, which is 49. So that tells me 7 times 49 is 343, or 343 divided by 7 is 49. Okay. We can do another example of those. Let's do 150 divided by 6. So if I'm doing the missing factor method, I'm going to turn this around into a multiplication problem. 6 times what is 150? Well, I know 6 times 6 is 12, so that tells me that 6 times 6 is not 12. 6 times 6 is 36. 6 times 2 is 12, so that tells me that 6 times 20 is 120, so let me do that. So 6 times 20 is 120. How much are we short? If I want to be at 150, this is short 30. So 6 times 5 equals 30. And so now 120 plus 30 is 150. So my answer is 20 plus 5, which is 25. So that tells me 6 times 25 is 150. And then I can turn it around. 150 divided by 6 is 25. Okay, so breaking it apart into a multiplication problem and thinking about the pieces for multiplication. Okay, our last method is using base 10 blocks. So let's do a base 10 block problem. And base 10 blocks is using partitioning. Okay, so I'm going to do 75 divided by 6. So my thought process here is I have 75 things, divide into 6 equal groups. Okay, so 75 things using base 10 blocks would be 7 longs, 4, 5, 6, 7, and then 5 units. Okay, let's put this into 6 equal groups. So here's my equal groups. 1, 2, 3, 4, 5, 6. So now let me see what I can split up. Can I put my 5 units equally here? No, because I have 6 groups. So let me start off with the longs. So I can put along here, along here, along here, along here, along here, along here. And so now I have a long, 1 long and 5 units to split among my 6 groups. So I can't split that long evenly like that, so let me regroup it. 2, 3, 4, 5, 6, 7, 8, 9, 10. I know that 1 long is the same thing as 10 units. And so now I can put a unit in each group. So 1 unit here, 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 so on and so forth. Keep on going until you can't either run out of units or you can't equally divide them. So now each group has 1 long, 2 units in it. What's left over? I have 3 units left over. Can I split those 3 units equally among the groups? If you wanted to get technical, you could split them in half and have half a unit, half a unit, half a unit. We're just doing whole numbers right now, so we're not going to worry too much about that. So your answer here is how many are in each group. So how many in each group? And in this problem, we have 1 long, 2 units, which would be 12 in each group. And what's left over? So 12 with 3 left over. So the way we would write that answer would be 75 divided by 6 equals 12 with a remainder of 3. Okay. So that is your strategies for division. So if a student asks, how do you do this problem? How do I divide 75 by 6? There are 4 different options there. A standard option, the scaffolding method, the missing factor method, and then the base 10 blocks.